co-chair of the SOC and also chairing this morning session. So before we start the conference, just a few words for myself. So this is a conference, of course, I discussing a variety of science studied at high-level institutions. But of course, more importantly, this is a conference. Celebrating our whole who is mentor and supervisor or whatever, celebrating his retirement. He retired in 2001, right, already? 2001. 2021, so. 2001, right. But anyway, but still, we start discussing this conference, actually, back in 2019. I think Chiou and Caltech and coordinated. I started talking there was an occasion during the ASIAA conference. Then later I also joined. But as you know, because of the pandemic, we have to keep postponing. Then eventually we had an occasion to get together. And I'm very happy, many people coming to this conference. Okay, so then that's something I just tell. So first of all, I think I need to ask Lady, Director of the ASIAA, give opening remarks. Thank you.
Okay, well, welcome everyone to Taipei. I think, given that most of you know Paul, that means all of you have been to Taiwan before. In fact, raise your hand if you've never been. This is the first time in Taiwan. Welcome. It's never too late to come and spend Taiwan. I think it's a great occasion and great celebration, a number of events that we've had over the last couple of days. Last week we had the 30th celebration of the Institute, and Paul was director over half of that time period and had the key influence on shaping this institute. So I think the institute is what we are today in large part due to Paul. So this week is a special opportunity to focus on some of the history and especially the legacy. I think is what is particularly interesting. This is not something which was in the past, but it is something which lives on and goes into the future. I think this is what makes it particularly significant. And I think we are all very fortunate that we have this environment that got built by Paul in large part. And I look forward to hearing about many of the results and the science and the future, and to look at where to think about how this could have happened. I certainly take a lot of lessons from this and think, what do we do today? But what will it mean in 10 years' time, in 20 years' time? So this is really exercise of vision, looking forward, looking past. And I'm glad that there's so many joining us on this very fascinating meeting. So I also get to say the last talk in this meeting on Friday. So I'll be talking about some of my personal interests in high resolution measurements. So I don't want to say on Friday.
All right. So then the next speaker is one another friend, I think more story about, I think he's yourself, right?
Well, we'll see. So I've already suffered through 2 days of talks. I told you guys not to talk, but you guys couldn't help yourself. So at first I thought when Ariyoshi says, you must say something, I thought, this is terrible, I don't want to say anything. But now I prepared 100 slides. Let's see how you like that. So, I should pull this slide up from when I first came in 2004 to take over the Institute the second time, replacing San Fox tenure. At the time, I was going around to introduce myself to the community. So there were a few things that I wanted to point out at that time, like who am I, right? Doesn't matter. So, who am I? Well, I was made in Hong Kong, as they say. I immigrated to U.S. when I was 10 or 11. The most impressive thing I remember from that day, if you were from New York, were actually baseball. It was Roger Maris and Mickey Mantle was imprinted on my mind as to what life is all about, which is to hit home runs. Right? So that's a lesson in life. The only thing is home runs. Singles don't matter. Okay? And competition is very important. Those two guys were competing against each other, but in a friendly manner, right? And then after that, of course, I was educated in MIT, and you see the middle row. MIT, of course, is a very important part of my life, but actually the left side of MIT is the dining hall. So the dining hall is actually very important to me because food is very important, right? So that's all I remember that MIT is about eating. And then after that, of course, I spent my time postdoc at UMass and Berkeley, and you can see the Berkeley array over there. And then I taught at Harvard. And during that time, I was very influenced by the Nobuyama telescope. Okay, why was that so impressive? It was actually because when I went to Nobuyama, I realized astronomy in Asia was building up very quickly. And Japan was doing a very powerful job to try to catch up. And they did not just join any project or build small projects. They went for the big things, bigger than what the Americans had, right? So that made an impression on me, that if you want to get ahead, you actually need to build very large facilities. And then, of course, I spent a lot of time at the VLA, and then by that time we built the submillimeter array, which Jim is going to talk about shortly. And then, of course, this was a key thing in Taiwan. We're building the SMA and also working in Amoeba. But note that even in 2004, the most important thing to me was in Taiwan. It's the reason why I'm here. Because of Taiwan. Okay. Now, people ask me about, do you have any pictures when you were a kid? So I couldn't find them. But Elizabeth actually found these pictures the other day, and she passed them to me. So this was me. You can see I was tortured from a young age. My parents put me standing on some terrible piece of rock. They told me to hold still. And then you can see that most of the time I'm crying, and, being in hot water, being trained to be a gangster with my pistols. And then most interestingly is this picture, which was in this balcony in our apartment in Hong Kong. And that was a very important piece of part of my memory, because through those slats in the balcony, we used to shoot rockets at the neighbors across the street and try to get into their apartment without them seeing where we were. So this is my brother and my plotting. So my life in Boston is actually pretty nice, I thought. You can see mostly I'm drinking, being a gangster, driving my Porsche, and then my yard is really beautiful in the summertime, but actually in springtime, this is a spring where the flowers are out. Already we are snowing a lot, still the last snowing season, and this is where we live in this place for many years. And if you're in Boston, please come to visit. That's the reason why my wife and children never came to Taiwan. Right? They were perfectly happy there. Why would they come here? They said. But of course, in Taiwan, also many wonderful things happen, right? And I just randomly pick out a few things. Most important, perhaps, is mangoes. I ate a lot of mangoes. There were beautiful sights. This is the picture of Tan and Patrick getting married. That picture was really nice. And then others of our staff, Shirley and getting married. And of course, I tried to match Cindy in her. Where's Cindy? This is meant for her. Is she outside? And then, of course, I tried to be fashionable with Cindy. But you can see that our staff is actually much more fashionable than I was ever was. So to me, Taiwan, my life in Taiwan was also very colorful and a very happy life. My family members, people say, who are your family members? Where's Jess? Jess always said, I don't believe you're married. I've never met your family. Jess, this is my family, my wife here. And you can see here that Elizabeth only had eyes for the children. Right? And there's no real picture of her looking at me. And my children have their own passion. So if you talk to my daughter, she will say, the most important thing is my horse. And for my son, the most important thing is Italy. He would say, sono italiano. He would get his wine. And then my dog, who thinks he's actually the proprietor of the property. He always occupies my chair. This picture is to show the ranking in my family. Elizabeth, Emily, Ted, dog, and then me. Okay, and then of course, actually, my family here, these are my students and postdocs at this meeting in Alma meeting in Dhaka. You guys will remember that, some of you were there. And it was really a great day because, amazingly, most of my students and postdocs were there working on Alma. Right? Not all the students were there, but we hope to update these pictures. But most importantly, I want to point out a picture on the left. This is a picture very early on. The person sitting on the left is Robert Escalera, and half of my students are actually his students whom he sent to work with me at SAO. So we collaborated for a long time. This is part of my Spanish Mexican mafia that's sitting up here. You can see Chima sitting in the background, fighting what he was going to do. So then people say, what is it that you do? Did you think about what you were doing? And it's easy to say, as we say, ex post facto, meaning after the fact we know what we're doing, right? So it's good to say that I had a strategy about how to do it. And here's some of the strategy, right? The key in making progress is actually to develop new technology. And the Institute was built here, basically pushing the technology in. Right? And how far do you have to go? Typically, you need to improve by a factor of 1,000. Factors of 2s and 10s don't mean much, right? But if you can make a breakthrough in your technology, in your abilities by factors of 1,000, whether it's sensitivity, whether it's resolution, whether it's time resolution, this is actually the key to breakthroughs. I'm pretty convinced of that. Ex post facto. Can anyone who worked with Frontier, as in Taiwan, we demonstrated this? Yes. How to find the right problem? Actually, the key is to find the right people. You know that in the last 2 days, I keep saying, right? The most important thing I've done was to recruit the people who populated our project. It's the people who actually make things happen. And how do you find the right people? Actually, of course, you have to work with the right problems. You have to work with the Frontier, who would want to work on things that are not exciting, right? So how do you get resources? Of course, you need godfathers, godmothers, and then where the goal is always new. There's no point in doing things that we've done before. We are always after the new directions. And people always know that, but I always say persistence is the key, and that you always have to think that the next step, the next future will be better. Okay, how do you like it so far? That's only 10 slides. Keep going. So I want to tell you that, research is not always straightforward. There are many missed opportunities along the way. And again, only you know that looking back, you will realize what you missed. So the key is actually trying not to miss this, right? So the first opportunity is gravitational wave detection. People say, what do you have to do with that, right? What do you know about gravitational wave detection? Well, it's about this guy, Ray Weiss, who was one of the key persons. Actually, Taylor was also interesting because Taylor came back from Arecibo with this detection of the spin down of the pulsar. I remember very clearly, I was a pulsar at UMass. He came to give a talk about the spin down. You know why? It's because the precision of that measurement was so accurate, they would actually see the slight spin down of the ray due to the gravitational radiation. Immediately I thought, this must be a Nobel Prize. Right? He was just a professor at UMass. And almost instantly, Princeton swooped in and hired him away. Right? Didn't need publication papers. If you know a good thing, you just go get him. And then Ray Weiss was a young faculty. So the story on this is that, of course, quantum theory of radiation was very important. Without Einstein, we couldn't do this, right? But it's really Charlie Towns in the 50s invented the maser and the laser. Okay? So based upon that, the laser technology became important. Why is that? Again, because of high resolution provided by lasers, right? So in the 60s, he got the Nobel Prize. In late 60s, we were all working on lasers. When I first arrived at MIT, my advisor says, come to seminar in the evening. Of course I said, I had many classes during the day. Why would I want to go to seminar again at night? And he says, we have donuts. That was another lesson for me. Food is key. The way to attract people is food, right? So those of you who've been in my group meetings know how that works. Food will bring you in, right? So of course I said, oh, donuts, I'm there. So at that evening meeting, the seminar, which I try to replicate here, we are always discussing what is the next thing to do in physics. We were thrashing around constantly discussing. And Ray Weiss was there as one of his young faculty, and he was actually at that point working on the CMB and using laser technique. Of course, out of that is that experiment to detect gravitational wave using laser interferometry, right? Of course, at the time I spent 3 years working on lasers, and at the end of that I thought, this is just hopeless. This kind of backbreaking work, never getting the data, always tearing down your instruments. Instrument building is just for the birds, So I gave up doctorate of physics and went off to work on astronomy, although I did work for a town student, Al Barrett, but definitely was not on instrumentation. So that was mistake number one. Major mistake number one was to get away from the instrument. Number two, missed opportunity was black hole. Now here is a picture you saw yesterday of Reinhardt and Fred and I think this was in Hakone meeting. At that point, we had already been working together. In the 80s, Reinhardt and I were in Berkeley. So the backstory on this, again, is about Towns, right? Towns went to Berkeley from MIT, built this group working on galactic center and measuring the motion of the gas around the galactic center. Reinhardt and I showed up in Berkeley, and one day he says to me, I'm giving up PLPI, I'm moving into infrared astronomy. Right? That's Towns with infrared astronomy. And I said, Reinhardt, why are you doing that? He says, well, actually, I don't know. And I said, what? You don't know? And definitely, I'm not going that way, right? How can you not know what you're doing and you're heading in that direction? Well, the thinking there was actually he wanted to build instruments. right? So he worked with towns basically to learn about instruments. And 10 years later, began to work on the orbit of S2, quickly defining the orbit of that S2 star. 50 years later, the Nobel Prize was given for this laser-enabled geometry work. What I remember at that time, again, it's about eating. Reinhard and I did a lot of eating in Berkeley. Very famously, this dim sum dish on the right, he didn't know what to call it, he just called it that slippery noodle dish. And we would be eating that, right? So food was very important, but again, I thought I would work on interferometry to improve resolution, because I thought that was obvious 50 years ago, right? Not so obvious. Okay, now we have done this. Here we've done the GLT project, and we have actually, in this last year, published this connection between the black hole and the jet, and actually studying the accretion matter by resolving. Okay, but the purpose of this picture is to tell you that the resolution improved by a factor of 1 million by the time we got to this. Because when I started, what I thought was high resolution was 10 arcseconds. Right? 10 arcseconds in the 1970s was very high resolution. But as you see, if you want to do something significant, you actually have to go a factor of 1 million. Okay? So what's the backstory on this? CHAMPS is involved again, of course. Always has to do black center, and then this run of development. I starting with Fred, thinking that there's black hole in the galactic center. Typhoon push for astronomy. We made a preparatory office. We built the SMA. We started the VLBI. We built Buck, and built ARMA, and then we built the GLT. Right? So there I am on the right, being influenced by towns in a very early meeting in Germany, where we discussed the black hole. Now, what have I done in 30 years? The key is that Din Tai Fung is everywhere in the world. So I can actually go eat Din Tai Fung anywhere in the world. That is a great achievement. So one of the important things in life, you often told me, I just want to repeat this message to my students and colleagues, young colleagues. Life is not about work. Okay? So you really have to find the balance outside. You need to find always a good mentor, a good boss, because they need to show you the way of how to do things. Right? Working in new directions is very important. It's in this unexplored parameter space. And when Jim will tell you about the SMA next, the driver for the SMA was actually we're getting into this unexplored parameter space. Greatest way to learn is actually to explain, right? So the young people, the most important thing is to explain what you're doing to the student, to your friends, because only when you explain do you realize how much you really do not know and do not understand. Right? We all think we understand until we start teaching and have to explain to the children on that question why, right? So explaining is actually very important. Appreciate your students. I can tell you they're better than children. They're better than your own children. So value your students. Appreciate your bosses. And here I'm talking about my administrator and my staff. They are my bosses. I really, all of you have to recognize that the bureaucracy is solved by your administrators. Take care of your people. Why? Because they're yours. The most important thing you should do is listen. As you get older, become manager, your time is the most valuable asset for you to share with your people. So listen, and then of course be humble, because I can tell you, you're not the smartest. The smartest ones are out there. So you must always be very humble. There, not 100 slides, just 20.
Okay, so any comment, questions, suggestions? Please. Is there anybody who can pass the microphone?
Could you go back to that last slide, please?
Oh, no.
Oh, well, anyway, just one point on that.
So your first point was find happiness outside of work, which I think is fantastic. When did you realize that? How early in your own working life did you start to see that that was a very important?
I would say it was in my 30s. Before your 30s, we are very focused on our job and being secure and what to do in life, right? But in your 30s, you will begin to realize that actually, as many of my students will tell you, I always tell them, go get married and raise a family, right? As soon as you have family, you will realize that life is much more than work. And you will never be happy just being at work. And the life part is actually what sustains us outside of work. If you're happy outside of work, your work will go better. If you're not happy outside of work, you're just going to be miserable by your work. You'll never really be happy. And if you pour all your energy into work, you've actually wasted the most important part of life. And you don't know that until you've actually tested yourself in the job arena and tested yourself in doing research and see how far you can get. And then you have to stop and think, right? Was that really worth all the things that I was doing? So I would say being happy is truly important. Dalai Lama, go read Dalai Lama, he will tell you.
Any other?
Not fortune cookie.
Another fortune cookie. Any other questions, comments? So anybody from online, I want to ask questions. Are you happy?
Jim is one of my Buddhas.
All right, so then let's move on. 34. Okay, so next. Oh, sorry. Hien, yes. Can you turn on your microphone? Then you could turn on your video as well if you like. But anyway, turn on the microphone and ask a question. Hello?
Can you hear me?
Yeah. I'm with you. Yes.
This is simple. I think that question for all. In the list of this opportunity, let me see. The CMB, I wonder if you consider the CMB is missing opportunity. I think been seduced by the CMB.
Well, CMB, no doubt, is very important, right? At IAA, we also did the CMB experiment. But it's extremely difficult. The early work, I think, every step of the way was extremely difficult to do. And as far as we might, on the CMB, it was very difficult to do it as a small group and small institution to make really great progress. That was the problem. Right? The most interesting thing at the moment for CMB is clearly B mode. But B mode, as you know, is truly difficult experiment, and the instruments have to be very good. The preference why I would say against CMB work is that it's harder in that field for many people in a team to actually work on it and gain credit and gain the recognition, right? Because it's a singular goal involving very huge teams. So that's why I favor SMA, ALMA, BLBI, optical astronomy, surveys, because many people can make this frontier research in those fields at the same time.
Okay. Thank you. All right, so any more questions? From online later. All right, so then let's move on. So let me introduce the next speaker, Jim Moran from Smithsonian. He's going to talk about the estimate construction and how Paul worked on that. So Jim, can you turn on your microphone and please start.
First share the group.
Wait a moment.
think everybody can see the screen and hear me. Well, I'm very sorry I can't be there in person to share the camaraderie and talk to you all, but this oral presentation will have to suffice. I'm very happy to be able to honor Paul Ho at this meeting. Now, let's see.
Yeah.
Paul and I go way, way back. I wanted to actually say something about this first picture. I have no idea when this photo was taken. I was trying to judge by the color of our respective hair. And so I judged it was about 1990. I think it was a meeting in Shanghai, so maybe Paul can correct that impression. Anyway, Paul and I go way back. We were both PhD students of Alan Barrett at MIT. My thesis in 1968 was called Interferometric Observations of Galactic OH Emission. It was the first VLBI of the spectral line. Paul graduated in 1977 with his thesis, a study of the ammonia molecule in the interstellar helium. That was just before he started focusing on the galactic center. So we actually authored 33 papers prior to the EHT era, 1976 to 2018. And four of them in particular. Our first paper together was we tried to do a VLBI experiment on the methanol maser in the Orion Nebula with a VLBI experiment. We didn't detect it, so we only came up with a lower limit. But Paul's interest in VLBI goes way back. Then in 1980, as Paul referred to the Mexican-Spanish mafia, we first linked up with Luis Rodriguez in 1980 and made this very comprehensive survey of everything we could do with Purgatorio objects. Also, the same year with Luis, we discovered the bipolar outflow in ASIAA. This was contemporaneous work with Snell, Moran, and Planback. They got more press because their spectra was they could distinguish the red and the blue shift better. It was sort of a more obvious case. And then we wrote 7 related papers on bipolar outflows. And then the SMA came along in 2004, and Paul and I and Fred Lowe wrote the lead article in the special issue of ASIAA on the SMA. So let me talk about the sub-millimeter array. Oops. A sub-millimeter array began essentially when Erwin Shapiro became director of CFA in 1983. He launched a plan to develop high-resolution astronomy across the EM spectrum. He even had visions of doing X-ray interferometry, which I think is still 100 years off. Anyway, he commissioned a committee, of which Paul and I were on, to study what can be done in the sub-millimeter part of the spectrum. At about the same time, there was a famous advisory committee to the NSF, led by Barrett, the so-called Barrett Committee, about what to recommend that the U.S. should do in millimeter astronomy after the 25-meter dish was not funded. So in 1984, our little committee, instead of acting on what Erwin Shapiro had in mind of having a 2-element interferometer in Arizona, he suggested that we ought to plunge right in and build a 6-element 7-millimeter array. He was kind of shocked, but he liked the idea and he really promoted it. Our first activity was in 1989, 5 years later, when our sub-millimeter receiver lab was established. In 1990, the Smithsonian Institution established a major scientific instrumentation program, and the first project was the SMA, and the funding began to ramp up at that point. So here are some of the key personnel involved early on in the SMA. I was director after 1995. Paul Ho was a project scientist throughout his time at SAO. He was not at all limited to being a project scientist. He stuck his nose into every aspect of the project. At the same time, in 1990, the first discussions were happening at the Academy in Taiwan between Typhoon Lee and Frank Chiou about initiating a real astronomy program and institute. The first thing that Frank did was call Paul Ho into the discussion, and they were later joined by Chiou and Fred Lowe. The design study of the SMA was finished in 1992. And then, after we've been working on things for 4 years, Y.T. Lee, who was the president of the Academy, Seneca, approved funding for 2 additional elements in the SMA, and a memorandum of understanding of a partnership between SAO and ASIAA was signed with an 85-15% split in the observing zone. In 1998, the first fringes were obtained at 230 gigahertz at Haystack Observatory, where we set up to build the first antennas. That's in Western Mass. And then 5 years later, the whole construction was finished on Mauna Kea. We dedicated the instrument and went into full operation with the 8 antennas, 6 from SAO and 2 from ASIAA. And then I wanted to mention that something very dear to Paul's heart, in 2008, the first proto-EHT observations of Sagittae occurred with the VLBI array that included the sub-millimeter array as one of the 3 elements. That was the first to measure the actual size of Sagittae star and put a Gaussian equivalent diameter of about 43 micro-arc seconds on it. So here's what the initial proposal looked like for the sub-millimeter array, and here was our team of people who actually came up with the detailed specifications, and this actually served as the proposal for the SMA. The initial cost was $25 million, was the estimate for 6 elements at a U.S. site. And then that crept up in 2003. To be really honest, it's hard to get people to be completely honest on how much the project costs, but the estimate is about $100 million as built with the contribution of ASIAA, plus an extensive early science program thrown in, and building it on Mauna Kea. You can compare that to the Alamo, which in 1990 started out as a $120 million project. The U.S. proposed the NSF called the MNA, 48-meter antennas, and by the time we had project creep and budget creep in 2013, that cost about $1.2 billion. Here's what astronomy at millimeter, sub-millimeter wavelengths looked like in 1984. 3 millimeter interferometry was just getting going. Creek, Overo, and Iran had 3 elements interferometers. It was pretty hard to make images of those instruments. Nguyen was working at a 5-element array of 10-meter dishes. For the single-dish instruments, which were pushing beyond 1 millimeter, there was a CSO 10 meter, the JCMT, the Arizona MPI 10 meter, and the University of Columbia 3 meter telescope. These mostly had very noisy Schottky diode mixer receivers with complex LO sources. SIS mixers and gun oscillators were in their infancy. So the thought of doing sub-millimeter interferometry was quite daunting because the receivers were so noisy at that time. But it was expected that they would improve as the Schottky mixers had improved over time and would become very sensitive, and that has turned out to be true. So Paul spoke to you quite a bit about the galactic center and Sagittarius star, which has become one of his major focuses. Back in 1984, all that was known about the radio source, Sagittarius star, was that it was compact, but its size was completely determined by interstellar scattering, all the way from 30 centimeters down to 2.2 billiard seconds at 1 centimeter, 1.3 centimeters, not millimeter, 1.3 centimeter wavelength. In the infrared, at 2 microns, Towns and Genzel were just beginning to look at the neon-2 gas emission, which was suggesting a compact source. So shortly after Genzel told Paul he didn't know why he was going into infrared astronomy from ELDI, he was deeply ingrained in the Galactic Center program started by Towns. So finally, when we come to Paul's contributions to the SMA, as I mentioned before, Paul was not your ordinary project scientist. He studied every aspect of the project. He was part of the original team that conceived the SMA in 1983, and he was the original project scientist. He, as I mentioned, had a way of delving into every part of the project. At one point, he was dealing with the contractor from Germany to supply some system for the SMA, and then he invited them all over to the U.S. for a project review, and he had to organize a dinner at a very fancy Italian restaurant for about 20 of us. And so we all sat down, picked up our menus, and Paul promptly called over the maitre d' and told him simply, "Please bring us some food." Oh, the director, Rory Shapiro, was quite shocked when he got the bill for that dinner. Anyway, Paul emphasized his needs, which he had to do. He was also in charge of recruiting postdoc fellows and staff, and he established the postdoctoral program at the SAO in 1990. And this had some very interesting collateral benefits. For example, one of his students, Eric Chiou, stayed with the project and came up with a very innovative layout layout for the antenna is called a willow triangle. So we started forming the foundations in the form of a willow triangle, but then when ASIAA came along, we had to add them extra pads in a sort of ad hoc fashion, so that didn't all turn out as originally planned. Oh, the postdoctoral program has also led to a lot of rather long-term staff members in the project. For example, Mark Burwell was one of the early postdocs, and now he's been with the project almost 30 years and is an indispensable staff member. I wanted to go back and mention about the SAO and ASIAA collaboration. This has the obvious win-win of adding 2 antennas to the SAO-6, which double the number of baselines. But another advantage was that, for example, we had difficulty with some of our contractors, and the contractor we had for the carbon fiber tubes, that backup structure actually defaulted. And because ASIAA could move more nimbly with contracts, it was able to line up an excellent source of carbon fiber tubes in Taiwan, which is related to the giant bicycle company. One final thing I wanted to mention was that Paul was an early advocate that we had to get going in the receiver lab first of all. And he really pushed that very hard, led us to establish the receiver lab even before the funding for the SMA itself started, and that was a very wise counsel. And of course, Paul, as usual, was always pushing hard on every aspect of the construction. I can remember once Paul told me as the schedule was slipping on certain items, he said, "Jim, they're looking at this the wrong way. This is the time to not delay the schedule, but to advance the deadline by inspiring the team." So I tried to do that with only partial success. So let me just conclude by saying how pleased I am to be able to celebrate Paul's ongoing career in radio astronomy. Thank you very much.
Thank you, Jim. Thank you very much. All right, is there any question, comment? Anybody? Anything from Paul?
So, Jim says my interest in VLBI was very early on, right at the beginning. Actually, Jim, it's not true. Alan Barrett told me to stay away from the VLBI. Did you know that?
Yes, I knew his heart was not in it. Well, yours was.
However, what I was really attracted by the VLBI was actually not about VLBI, it was about working with Jim. And we used to fly down to Charlottesville with this little plane. So I thought, Jim, he's such a nice guy, he's taking me along to do the experiment. Not only that, he wants me to fly along with him. But alas, that wasn't the reason. He wanted me to pay for the gas and the air flight. He just brought me along as a fuel tank filler. We had a great time flying down and doing experiments, right? In this little planes with Jim. Of course, I didn't realize how bad a pilot he was because I was too young also. We had adventures after adventures in this, which made me think that the VLBI was a very important technique. At the time, I worried about it a lot because the early VLBI guys are all very tall. And, physically, I thought I couldn't measure up to the VLBI standards. But in the end, you can see VLBI is clearly the way to go. to achieve the resolution that Jim has pushed very hard on. I just want to mention that in my career there were a few instances where I heard a talk and I thought it was Nobel Prize quality. One was when Taylor came back from Arecibo with the spin down measurement. The other one was actually Jim's measurement of the high velocity masers and defining that disk. I thought that was Nobel Prize likely. Did I tell you that, Jim? Maybe not, huh? I thought that was really up there in terms of the achievement in what we were doing in terms of eliciting real scientific results. In my mind, was even stronger than the black hole orbital motion, because that one was really a tour de force. Thanks.
Let me remind the organizers that is very tour for us online. Well, I got most of what you said, Paul. I spent a couple hours actually in the last week trying to find the photo that I have of you in 1976 standing on the wing of my plane, trembling about the trip.
Okay, any more questions? Anybody from online? Oh, sorry. Ooh. Somebody raise a hand. No. Hien, do you still have a question? Your hands still keep raising. Maybe not. Okay, so then let's move on. Thank you again, Hien. Next speaker, I would like to introduce the Chu-Hsiang from Beijing, China. Chu-Hsiang, can you come on your microphone and the video? I don't see his name here. He's on? Chu-Hsiang, can you hear us? Hello? Hello?
He's online, but he doesn't respond.
Okay. He's sleeping probably.
The speaker's not. The speaker's he's online, but
Sorry, that's late.
okay, so we need to reboot, so next.
Okay, we are so sorry. Wow, this is difficult to talk for the remote session. I never use a computer, so we are going to get Chu-Hsiang later. Then speed, we like to have local people talking in person. I'd like to introduce Eric Chi.
Jian sent me a message. He's having trouble. But he sent me his file. He says, if you can't do it, I should give this talk, but I don't think I should give this talk.
I will try. Alright, so then I would like to introduce Eric Chu from CSISST, but he cannot come here in person here today, unfortunately. So that instead, Eric, choose on show. I'm so sorry, my translation is awful, as usual. Can tell us what he has done locally, what Paul has done locally here.
Good morning, Professor Hall and ladies and gentlemen. Please. I don't have 100 slides or even 20 slides. Sorry to disappoint you in such a conference that without any slides, just a piece of paper.
No slides.
Yeah. Actually, I'm quite new to this community, I believe. I would like to introduce myself, Chiou from NCSIST, and Bill Sands. We probably worked with Paul for last 20 years, and we build instrumentation and the equipment. It's great to be here to honor his contribution. Although that astronomy it's Greek to me, most likely. But I find that two keywords, by the way, I need your slides. Your slides are very painful to me. Food and the restaurant. And that's bonding us together. Now I know your secret strategy. We work from ALMA, the front-end test facility, and till GOT all the way up to now. And it's great to know him. He always amazes me with a lot of knowledge, both on the science part, on the work part, and also on the food part. Well, you know he's a good teacher. From this conference, you can see that with a lot of distinguished students. He's a pretty good scholar or scientist, I believe. Probably from his speech, you can see a lot of Nobel Prize laureate. I think it's among the talent. But I'm not talking about this since in these few days, probably you know more about astronomy. I mean, to me, in real life, the black hole is someone covered a pigeon hole and you close to see that's black hole, no light. But recently, he discussed another project with me that's not on the astronomy or astrophysics side, but something dark Earth. And that's really touching. Because as a scientist, you know him, his contribution, anything, a lot of things that I can't put a word on it. But his focus on the Earth, on the climate change, on the CO2 reduction, I think that's not gonna help him on the science side. But I believe if this project succeeds, I mean, it will help us, human beings in the long run on the Earth, this place we call it home, and that's a decent human being. I'm very good. So all in all, I'll say thank you, Paul, for sharing with me all those fascinating knowledge, good stuff, your style. We all know him about his talk gently, smile frequently, but his determination to success, I think that's the energy, the power drive us to work with with him for so many years. Thank you, Paul. Thank you.
Thank you very much for the excellent answer. So any question, comment? Anybody want to know something more? Yeah?
I just wondering what is the latest project that you and Paul discussed on the climate change?
I think it's we work with Chu back in I think 2016. A project called Hien. That's to have a biomass transfer the biomass into charcoal farm, and you can use them to do many things. To bury it underground, to absorb CO2, and it has other commercial usage too. Okay.
All right, so any other questions?
Well, Chu-Hsiang is, I've always said that Chu-Hsiang is the ace in the hole for the IAA, because they are there to help us in all the projects that we've done for many years, starting from years, but Chu is just a long line of upper management in that organization who has supported us continuously all this time. And you have to understand that their mission is actually defense, but to help us as part of Taiwan's efforts in science is what makes this institute strong, right? I've said this many times. And this latest project, of course, is implementing Frank's vision that science should have application immediately, as soon as possible. And to save the climate, we have to do our best. So we're trying to implement this vision, and with that opportunity.
Yes. And I'm also working for this. Okay. Chu-Hsiang is now ready?
Yes.
All right, good. So thank you again, Chu-Hsiang. All right, so then let's move on. Now let me introduce next speaker, Hien, from JPL. Talking about the astronomy in Vietnam, which another thing is Paul also trying to help a lot. So Hien, please start. You could make a full screen if you like.
Can I start?
Yeah, but you can make your slides to the full screen if you like.
Right. Thank you. My name is Nguyen, and thank you for organizing this conference and for giving me the opportunity to share a few words about our wonderful colleagues world here. I'm speaking on my own behalf and also on behalf of my colleagues from Vietnam. Can you all hear me fine? Thank you. Right. So I don't have that many slides to show. But I only have one or two here because for this reason, although I was aware of this, I've come to know how the weight for those here compared to the community. I would say that these days, Asian names astronomers are plentiful to background graduate. Some 30 years ago, it was still a rarity. Back in the day, there's a couple of names that caught my attention. The The first one is Chu. That name came readily because my project at Berkeley, which was also Professor Chiou's home institute, and also the famous textbook, the introductory text to astronomy, and to this day, Chiou book is still, to me, still the best introductory textbook in astronomy. And the second thing that I was also aware of is Hong Ho. I wasn't sure, at the time I wasn't sure, I saw the name but I wasn't sure where it's from. And the last name Ho made me confused. I was hoping that maybe it's because of the similarity in the name. But I came to aware of this name for this association with the SMA, which we just heard Jim talk about. I should confess that I don't know anything about SMA. I only watched it from afar. Around the mid-90s of the last century, my former advisor, Ed Peterson, and I was thinking of making a large telescope CND series. At the time, we were thinking of fabricating a 2-meter class telescope for the 6-millimeter astronomy. This telescope was later become the LIGO telescope at the South Pole. And it's only 2-meter telescope, so it's not a big deal today, but back in the day, this is mid-90s, we didn't know about energy yet, remember? And then the acoustic peaks for the CMB was still 5 years down the road there until the work of Moran and WMAT. So basically, this 2-meter is a big deal at the time, and also it's an off-axis telescope. So basically, when you do the surface for the when you machine the surface of the telescope, you need to have a setup that going around a circle that as big as 4 meters. So in fact, is a respectable size for a low budget experiment like ours at the time. And so after we make the surface, we have to think of a way to measure the surface roughness, the RMS surface, and we was looking around for clues. And so we came across a company in Acton, Ohio, that apparently also do the measurement for the MA and also for the SMA later. I don't know whether that's in the house to you, James and Paul. But anyway, this is when I first heard about the SMA and called Moran. Later on, I looked at the CFO. And I saw the SMA coming together at the top of Mauna Kea around the year 2000. Still, I did Paul there for some reason. It would be fun to there. But so finally, I got the chance to meet Paul in 2016, just only 7 years ago, when Nguyen and I was organizing a workshop for developing a astronomy. We wanted to learn from pioneers in the region, and so we invited several leading astronomers from Japan, South Korea, and Taiwan, and of course, Hien and Temple naturally. I learned during this course of organizing the workshop that there were a number of young astronomers from Vietnam that worked with Paul, such as Nguyen and Temple, study there. Nguyen Trung is now currently the director of the Vietnam Institute of Physics in Hanoi. And Phan Bong Ngọc is a professor also at the Ho Chi Minh City International University. These people play a large role in developing astronomy in Vietnam and getting the observing time for Pira groups. Now is the groups in Hanoi, and they provide observing time on the Chu-Hsiang, which becomes a major source of observing activity for the group over the last several years. In Taiwan words, he said, Paul is a friend of the Department of Astrophysics at the VNSC. This is my translation of the words. Paul almost available to help when we meet him. He will provide us with information, advice, or comments on the project to build infrastructure for National Observatory. When our group was on the edge of being dissolved, Paul wrote to the president of the Vietnam Academy of Science and Technology to express his support for our group. And thanks to the support of Paul and others, finally, the group was still intact till today. As for development of astronomy in Vietnam in general, Paul has also been to Vietnam numerous times. He met and lobbied the science leaders in Vietnam to support development of astronomy. And then for our workshop in 2016, Paul helps Vietnam to become an observing members of East Asia Observatory. And I should note that Paul also done similar things for Thailand, Malaysia, for astronomers in Thailand, Malaysia, Indonesia, India, etc. In addition, he also gives public science talk, which exciting scientific activities for the young people there. As I mentioned before, we invited Paul in 2016 and again in 2018 for a record to Vietnam. During this visit in 2018, I had a wonderful opportunity to talk to Paul often on the campus of ISIS, that I showed here. Paul shared with me his journey in building up astronomy and astrophysics for Taiwan. He also took in a keen interest in my thinking regarding what may be done to push for the development of astronomy in Vietnam. Through this conversation, I can see that Paul cares deeply about science and education and research in this region. And he also a lot of fun to talk to. I really enjoyed talking to Paul and learning from him. I realized he's a great guy. And this is one of the greatest reward that I consider that I have in science. Meeting people like Paul, working with them, really one of the key reasons why we have such a good career and fun life altogether. 2 years ago, Tim, Juan, and I, the three of us, maybe I should show a picture of the group here. In this group, there's many leading astronomers in the region, but as you can see here, this is Paul. I don't know if you guys can see this picture. It's Paul right here. Phan Bong Ngọc is right there, and Nguyen Trung is standing all the way in the back. Let me see. Nguyen, who is there now at the conference, is right here. Hayashi, which is the director of AOJ at the time, is right here, and this is me in the back corner there. This is 2016 already. One of the lesson we learned from this workshop, for me personally, is to push for international collaboration. One of the ways to get astronomy to be carried out in Vietnam is to push for international collaboration. And 3 years ago, our group, which is including me, Nguyen here, Steve, and Quan, we put together a proposal on installations and to form a small group of astronomers, astrophysicists in Vietnam, and we got awarded this award. For this proposal, Paul played a role in giving his advice and also critiques, and we benefit greatly from his advice. We now have a group called Science Astrophysics Group, or STRIGE for short, ISIS, and thanks to this group, we go to come back to Vietnam more often and to train a new generations of astronomers in Vietnam. Also, slowly develop the infrastructure for instrumentation, astronomical instrumentation in the long run there. Let's see, how much time do I have left here? 5 years ago, 2018, Paul gave a talk when he shared his observation on the potential for astronomy and astrophysics development in East and Southeast Asia. Paul pointed out, I think sensibly, that this country in the region is going through strong economy, and with a strong economy, it will bring opportunities for science education and research. And now is the time for people like me and for like Moran and team to seriously consider to take this path and to follow it for example, like what is done with astronomy for Taiwan. One thing I took away from Paul's talk is this sense of optimism. Is optimism for the development of astronomy and science in general in the region. And my colleague and I share our sense of optimism and also a sense of responsibility. That it is our turn, it is our time to try to give science to our people, and that we just, plunge ahead and opportunities will arise if we participate. I hope the next generation, the younger generation, will continue to have colleagues in the region like Paul that would work with them and would help with them. We share the camaraderie, but similar to what Paul has given us and my colleagues in Vietnam. So lastly, I want to take this opportunity to thank Paul for what he has done for us, and especially for a small community of astronomers in Vietnam. We wish to continue to have his support for many years to come, and I want to thank Paul for setting the good example, for his leadership, and above all for being such a great guy to have around. Thank you very much.
Thank you, thank you very much. All right, so any question, comment? Anybody? Anything from Paul? Okay.
I just want to say thanks to Hien for joining the group in the meeting around each other, I think, to come to help us in our future, which is really great. Paul is here too.
Alright, so any questions from online? Alright, so then let's move on. So we just checked the schedule a little bit. So Chu-Hsiang, we're gonna ask him to give a talk after the break. So now I'd like to ask all the remote participants. Paul, don't get out. Yeah, okay, come back soon. Okay. I found the video and Paul is actually, step out. So, but I'm gonna ask all the participants to say hello or congratulations, but Paul is not here. Okay, Paul is here. All right. So then, others, if you like, you can turn on the microphone. But anyway, if you turn on the microphone, then I can say hello or congratulations or.
If they need a signal when to smile,
What?
you need to tell them when to smile. 1, 2, 3.
1, 2, 3.
Smile.
Smile. Okay, take a picture, right? Okay. Right, sorry. Okay, we're gonna going to take pictures. You are now everybody on the screen, remote participants on the screen now, so we are going to take pictures, and you can also turn on your microphone and say hello, congratulations, Paul. Yeah, here anybody say so. Yeah, waving hand, that's good. Yeah. Are you taking a picture already?
Yes. Yes.
Alright, so you can hear you as well. Okay, I'm gonna say 1, 2, 3 again.
Yeah.
Wow, look at you.
Okay, so 1, 2, 3, smile. Okay, alright, yeah, I know, Tana was smiling. Alright, but anyway, thank you for your remote participation, and we will still continue. Can we continue still? This is late. Yeah, we are supposed to have video now, video message. Alright. Okay, then we want to present the video messages. Those people, many people, including those cannot physically come in Taiwan, but they sent us the several video messages. So now we have to show the video messages. Yeah, search first.
Yeah.
Video message. Not yet.
Oh, yeah, search first.
I think
Group photo first. Okay.
你的 video message 在哪里？是在这边。video message
在这里啊。对啊。
group photo and video message is okay. Video message 在哪里？
在这里啊。
对。
Group photo first.
Yes.
Okay.
So give me some. Yeah. So group.
Very experimental. So, but anyway, okay. Then let's take a group photo. Let's take a group photo now, and you're probably gonna help us to take a group photo.
Please ask them to stick everybody to the center.
Oh, okay. I need to squeeze to each other. Really. Don't be shy. Don't be shy. One second. Yeah, please go ahead. So is that good enough? Yeah, you guys also enjoy, of course. Yeah. All right. So let me sit down. All right. Hi, Jim. Can you hear us?
因为他没有 video， 对，他没有 audio。
等一下。Louis, Eric, I need to know the microphone. Where are you?
No problem. Okay, 1, 2, 3. 1, 2, 3. Okay, final one more.
Still remember your
1, 2, 3.
ability?
Thank you. No, it's fine. Okay.
For the Fred Lowe tour.
Okay, 9, 8, 7.
Hurry!
1.
Wow.